Hello students, welcome to live class. Hi Banu. So in this live class, we are going to discuss in detail about the hydrogen spectrum. Students, screen visible to you? Voice audible to you? Okay, Abhilash. So at present, we are going to discuss in detail about the hydrogen spectrum. So especially hydrogen atom contains only one electron. So it is simple to study the spectrum of hydrogen atom. And this spectrum was explained by Bohr. Who explained the hydrogen spectrum? Yes, Bohr explained the hydrogen spectrum. So to have the better idea about the hydrogen spectrum, let us draw the orbits. So this is the first orbit. It is the second orbit. This is the third orbit. It is the fourth orbit. And it is the fifth orbit. Okay? Here n equal to 1, n equal to 2, and for the third orbit n equal to 3, for the fourth orbit n equal to 4, for the fifth orbit n equal to 5. So whenever an electron jumps from higher orbit to the first orbit, so let us suppose that it is the higher orbit. So whenever an electron jumps from higher orbit to the first orbit, then it results in the formation of Lyman series. Good evening, Raju. Okay, so whenever an electron jumps from higher orbit to the first orbit, it results in the formation of Lyman series. So, in a similar way, when an electron jumps from higher orbit to the second orbit, then it results in the formation of Balmer series. If an electron jumps from higher orbit to the third orbit, then it results in the formation of Paschen series. Similarly, when an electron jumps from higher orbit to the fourth orbit, then it results in the formation of bracket series. Whenever an electron jumps from higher orbit to the fifth orbit, then it results in the formation of fund series. సో ఏదైతే హైడ్రోజన్ యాటంలో ఎలక్ట్రాన్ అనేది హయ్యర్ ఆర్బిట్ నుంచి ఫస్ట్ ఆర్బిట్కి జంప్ చేస్తే దట్ ఈస్ కాల్డ్ యాజ్ లైమన్ సిరీస్. సో ఎలక్ట్రాన్ హయ్యర్ ఆర్బిట్ నుంచి సెకండ్ ఆర్బిట్కి జంప్ చేస్తే ఇట్ ఈస్ కాల్డ్ యాజ్ బామర్ సిరీస్. సో సిమిలర్లీ ఎలక్ట్రాన్ అనేది హయ్యర్ ఆర్బిట్ నుంచి థర్డ్ ఆర్బిట్కి జంప్ చేస్తే దట్ ఈస్ కాల్డ్ యాజ్ పాషన్ సిరీస్. ఎలక్ట్రాన్ అనేది హయ్యర్ ఆర్బిట్ నుంచి ఫోర్త్ ఆర్బిట్కి జంప్ చేస్తే దట్ రిజల్ట్స్ ఇన్ ద ఫార్మేషన్ ఆఫ్ బ్రాకెట్ సిరీస్. హయ్యర్ ఆర్బిట్ నుంచి ఫిఫ్త్ ఆర్బిట్కి జంప్ చేస్తే ఫండ్ సిరీస్. సో హైడ్రోజన్ స్పెక్ట్రమ్ కన్సిస్ట్ ఆఫ్ 5 డిఫరెంట్ సిరీస్. హైడ్రోజన్ స్పెక్ట్రమ్లో ఉండే 5 డిఫరెంట్ సిరీస్ ఏంటి? లైమన్ సిరీస్, బామర్ సిరీస్, పాషన్ సిరీస్, బ్రాకెట్ సిరీస్ అండ్ ఫండ్ సిరీస్. సో ఇఫ్ యూ కేర్ఫుల్లీ అబ్జర్వ్ దీస్ డిఫరెంట్ సిరీస్ ఆఫ్ హైడ్రోజన్ స్పెక్ట్రమ్, లైమన్ సిరీస్ అనేది మనకి యూవీ రీజియన్లో కనిపిస్తుంది. బామర్ సిరీస్ ఇట్ ఈజ్ విజిబుల్ ఇన్ ద విజిబుల్ రీజియన్. సో బామర్ సిరీస్ మనకి విజిబుల్ రీజియన్లో కనిపిస్తుంది. పాషన్ సిరీస్ ఐఆర్, బ్రాకెట్ సిరీస్ ఐఆర్ రీజియన్, ఫండ్ సిరీస్ ఆల్సో అబ్జర్వ్డ్ ఇన్ ఐఆర్ రీజియన్. సో కమింగ్ టు ద పాషన్ సిరీస్, ఇట్ ఈస్ అబ్జర్వ్డ్ ఇన్ నియర్ ఐఆర్. బ్రాకెట్ సిరీస్ ఈజ్ అబ్జర్వ్డ్ ఇన్ ద మిడిల్ ఐఆర్. Fund series is observed in far IR region. So here one should know what is meant by H alpha line, H beta line, H gamma line, etc. Okay, H alpha line means if the electron jumps from the third orbit to the second orbit, it results in the formation of H alpha line. So H alpha, beta, gamma అంటే సో బామర్ సిరీస్ అంటే ఏంటి? సెకండ్ ఆర్బిట్కి ఎలక్ట్రాన్ వస్తుంది. సో ఇమీడియట్గా థర్డ్ ఆర్బిట్ నుంచి సెకండ్ ఆర్బిట్కి ఎలక్ట్రాన్ జంప్ చేస్తే దట్ ఈస్ కాల్డ్ ఎస్ హెచ్ ఆల్ఫా లైన్. ఫోర్త్ ఆర్బిట్ నుంచి సెకండ్ ఆర్బిట్కి జంప్ చేస్తే దట్ ఈస్ కాల్డ్ ఎస్ హెచ్ బీటా లైన్. ఫిఫ్త్ ఆర్బిట్ నుంచి సెకండ్ ఆర్బిట్కి జంప్ చేస్తే దాన్ని హెచ్ గామా లైన్. క్లియర్? హెచ్ ఆల్ఫా, బీటా, గామా ఎలా వస్తాయి తెలుసాయమ్మా? సో ఇమీడియట్ ఆర్బిట్ నుంచి థర్డ్ నుంచి సెకండ్కి వస్తే ఆల్ఫా, ఫోర్త్ నుంచి సెకండ్కి వస్తే బీటా, ఫిఫ్త్ నుంచి సెకండ్కి వస్తే గామా. క్లియర్? ఎస్. హియర్ ద వేవ్ నెంబర్ ఆఫ్ these Lyman, Balmer, Paschen, Fund and bracket series can be calculated by using the formula wave number equal to Rydberg's constant into 1 by n1 square minus n2 square. So remember always n2 is greater than n1. సో మన ఏ సిరీస్లో అయినా వేవ్ నెంబర్ ఆఫ్ ది రేడియేషన్ క్యాలిక్యులేట్ చేయాలంటే మనం యూజ్ చేయాల్సిన ఫార్ములా ఏంటి? ఆర్ ఇంటూ 1 by n1 square minus 1 by n2 square. ఆర్ ఈస్ రెడ్బర్గ్స్ కాన్స్టెంట్ అండ్ ఇట్స్ వాల్యూ ఈజ్ ఈక్వల్ టు 109,677. సో వాట్ ఈస్ ద వాల్యూ ఆఫ్ రెడ్బర్గ్స్ కాన్స్టెంట్? 109,677 centimeters inverse. సో ఎప్పుడు n2 ఈజ్ గ్రేటర్ దాన్ n1. క్లియర్? సో సిమిలర్లీ we can also calculate the radius of the orbit. So in order to calculate the radius of the orbit, one must use the formula radius of nth orbit equal to 0.529 into n square by z. And the units are Armstrong units. N is the orbit number, Z is the atomic number. So always the ions containing only one electron. సో ఏ అయాన్స్లో అయితే ఒకే ఒక ఎలక్ట్రాన్ ఉంటుందో లేదా హైడ్రోజన్ యాటంలో ఓన్లీ వన్ ఎలక్ట్రాన్ ఉంటుంది. సో అలాంటి యాటమ్స్ అయాన్స్ యొక్క రేడియస్ క్యాలిక్యులేట్ చేయాలంటే మనము 0.529 ఇంటూ ఎన్ స్క్వేర్ బై జెడ్ అనే ఫార్ములాని యూజ్ చేయాలి. ఓకే, కమింగ్ టు ద ఎనర్జీ ఆఫ్ ది nth ఆర్బిట్, it can be calculated by using the formula minus 13.6 into z square by n square electron volts. So energy of the orbit, remember these formulas are applicable to hydrogen atom and also ions containing only one electron. సో ఈ ఫార్ములాస్ అనేవి హైడ్రోజన్ యాటము లేదా ఏ అయాన్స్లో అయితే సింగిల్ ఎలక్ట్రాన్ ఉంటుందో వాటికి మాత్రమే అప్లికబుల్. క్లియర్? సో ఎనర్జీ ఆఫ్ ది nth ఆర్బిట్కి ఫార్ములా minus 13.6 into z square by n square electron volts. Z is the atomic number, n is the orbit number. Clear? So let us discuss about the nodal planes. Before that, one should know the shapes of the orbitals. So what is the shape of the s orbital? Can anyone answer? What is the shape of the s orbital? S. The shape of the s orbital is spherical. Very good, Abhilash. Mahendra, Sai, very good. Now tell me, what is the shape of the p orbital? What is the shape of the p orbital? Very good, Mahendra, Tilak, Sai, Sahiti, Abhilash. Yes, p orbital is having dumbbell shape. It is the shape of the px orbital. This is the shape of the py orbital. Coming to the pz orbital, it is the shape of the pz orbital. Clear? Let us discuss about the shape of the d orbital. How many subshells are available? 5. Yes, very good, Mahendra. So the shape of the d orbital is double dumbbell. Very nice. Each and everyone is answering. Too good. So 5 degenerate orbitals are available in the d subshell. 1, 2, 3, 4, 5. So degenerate means they have same energy. So they are dxy, dyz, dzx. So here the probability of finding an electron is maximum in between the axis x, y, y, z, z, x. So in between the axis, there is a probability of finding an electron maximum. Coming to the remaining two orbitals, dx square minus y square and dz square. Here the probability of finding an electron is maximum along x-axis and also along y-axis. So coming to the z square, dz square orbital, probability of finding an electron is maximum along the z-axis. This is about the shape of the orbitals. Coming to the nodal planes. Always remember the number of nodal planes is equal to L value. You try to answer how many nodal planes are present per s orbital, p orbital and for the d orbital s. Dhoni, very good. For p orbital, let me check, you will answer first. Number of nodal planes for p orbital. Very good. Tilak, very good. Abhilash, Lalita, very good. So for p orbital, the number of nodal planes is equal to 1. And for the d orbital, so what is the L value for the d orbital? Yes, it's 2 and hence the number of nodal planes is also equal to 2. So this is all about the shapes and number of nodal planes. Sahiti, very good. Abhilash, very good. It is also possible to calculate the number of spectral lines. By using the formula epsilon n2 minus n1. Remember, always n2 is greater than n1. So for example, if an electron in the hydrogen atom jumps from third orbit to the first orbit, that means third orbit means n2 equal to 3 and first orbit means n1 equal to 1. Let us calculate the number of spectral lines. So that is equal to epsilon 3 minus 1. So epsilon 2. That means, can anyone answer? No, it is 2 plus 1, that is equal to 3. Clear? Very good. Geetika, very good. This is all about the number of spectral lines. How to calculate the number of spectral lines in each series. Clear? Now it's the time to discuss in detail about the multiple choice questions. Are you ready? So now we will discuss about the multiple choice questions, especially based upon the hydrogen spectrum, shape of the orbitals, nodal planes, and also on the number of spectral lines. So what is the first question? The electronic state in which the hydrogen atom can absorb photon but cannot emit a photon is. What is your answer? So hydrogen atom యొక్క ఏ ఎలక్ట్రానిక్ స్టేట్లో మనము ఓన్లీ అబ్జార్ప్షన్ చూడగలము, ఎమిషన్ చూడలేము. వెరీ గుడ్. అనిత, గాయత్రి, అభిలాష్, తిలక్, సోమశేఖర్, too good. So it is the 1s orbital. So an electron can jump from 1s orbit to the higher orbit. So it can absorb energy, but it cannot emit energy. So option C is the right answer. So coming to the second question. When an electron is excited, that means when an electron in excited hydrogen atom jumps from an energy level n equal to 6 to n equal to 3, the spectral line is observed in dash series. So here the electron is jumping from 6th orbit to the 3rd orbit, where we can observe the spectral lines. Yes, too good. Bhanu, Swati, very good. Lalita, Sujit, Gayatri, Sattar Khan, very good, too good. So, if n equal to 3, then what happens? Always the spectral lines are observed in Paschen series. Too good. So, coming to the third question. The equation corresponding to the wave number of spectral lines in the fund series. Come on, try to answer. What is the equation used to calculate wave number in the fund series? Fund series means electron will jump to the 5th orbit. Fund series means 5th orbit. Now try to answer. At once you think and answer. S. Gayatri, very good. Tilak, very nice. So fund series means N1 equal to 5 and N2 should be greater than N1. So this condition is satisfied by Abhilash, very good. Option B. So option B is the right answer. Clear? Let us move on to the next question. Which of the following electronic transition in hydrogen atom will require largest amount of energy? Before answering, you just think and then answer. Very good. Anita, Lalita, Sahiti, too good. So option C is the right answer. Why it is option C? Remember that always energy is inversely proportional to 1 by n square. So the least value will have highest energy. So option C is the right answer. Banu, Abhilash, too good. Moving to the next question. The relation between X-rays and gamma rays is, and here lambda 1 and lambda 2 are the wavelengths of X-rays and gamma rays respectively. So lambda 1 is the wavelength of X-rays, lambda 2 is the wavelength of gamma rays. So what is the relation between X-rays and gamma rays? Ma, you have to think carefully. Ma, do you remember electromagnetic spectrum? Yes. Bhanu, very good. Option A is the right answer. Why? Just carefully listen to me. Electromagnetic spectrum consists of electromagnetic radiations with increasing wavelength. So initially gamma rays will be present, next X rays will be present, next UV, next visible, IR, microwaves and radio waves will be present. Clear? So when you move from gamma rays to the radio waves, what happens? The wavelength increases, whereas the frequency decreases. Clear? So automatically the wavelength increases from gamma radiations to the radio waves. That means definitely alpha radiations will have greater wavelength than gamma radiations. So lambda 1 is greater than lambda 2. Clear? Very good, Swati. Vamsi. Yes. Moving to the sixth question. Which spectral series of hydrogen atom lies in visible region? Yes. Let me check who will answer first. హైడ్రోజన్ ఆటమ్ యొక్క ఏ స్పెక్ట్రల్ లైన్స్ విజిబుల్ రీజియన్లో ఉంటాయి? ఎస్ బాను, వెరీ గుడ్. ఇట్స్ బామర్ సిరీస్. ఆప్షన్ డి ఈజ్ ద రైట్ ఆన్సర్. క్లియర్? Moving to the seventh question. Yes, very good. Rajeshwari, Sahiti, Vamsi, too good. Coming to the seventh question. What is the energy of an electromagnetic radiation of wavelength? So wavelength is given. You are supposed to calculate the energy. Which formula we can use? Undoubtedly E is equal to h nu. You do the calculation. And here only wavelength is given. That is h c by lambda. Mu equal to c by lambda. H is Planck's constant. What is the value of Planck's constant? Yes, that is 6.625 into 10 power minus 27 erg second. And what is the velocity of light? 3 into 10 power 8 divided by, here let us consider in centimeters, 10. Next lambda 3200 and we have to convert into centimeters. That is 10 power minus 8. Do the calculation. Do the calculation carefully. Here the value of Planck's constant is taken in ergs second. So we have to mention the velocity of the light and also wavelength in centimeters. So it is 10 power 10. At once do the calculation and tell me the answer. Banu, do the calculation and tell me the answer. Swati. Sahiti. Here also no need of using the calculator. You can do rough calculation. 1. That means it may be around 6. And what about the 10 powers? It is minus 27 and here it is 10 and it is minus 8. Already 2 zeros are here. So it will be reduced to minus 10. Very good. Rajeshwari, so nice of you. So option A is the right answer. That is 6.21 into 10 power minus 12 erg. Very good, Gayatri. Yes, 6.21 into 10 power minus 12 erg is the right answer. Very good, Sahiti. Let us move on to the next question. The wave number of, again you are supposed to do the calculation, wave number of H beta line in the Balmer series of hydrogen spectrum. What is the formula for calculating wave number? Again we have to use the Rydberg's equation. N1 square minus N2 square. And remember it is H beta line. So for Balmer series, N1 equal to 2. And for H beta means for H alpha N equal to 3. For H beta it is equal to 4. And you just do the calculation and tell me the answer. Kerhack. Do the calculation carefully and then answer. Lakshmi, at once check the calculation. I think it will be into 3 by 16. Lakshmi, very good. Sahiti, Swati, Lalita, very good. Option B is the right answer. That is 20564 centimeters inverse. Abhilash, very good. Let us move on to the 9th question. Rebecca, very good. Moving to the 9th question. When an electron of hydrogen atom jumps from 5th orbit to the 1st orbit, find the number of spectral lines. Just now we discussed how to calculate the spectral lines. Anyhow, let us do the calculation. That is 5 minus 1, that is equal to epsilon 4. That can be written as 4 plus 3 plus 2 plus 1. So what is the right option? Very good. 10. So what is the right option? Sahiti, very good. Option B is the right answer. Tilak, too good. but you have to mention the option. Abhilash, very good. Banu, very good. Swati, good. Rebecca, very good. Rajeshwari, too nice. Let us move on to the next question. Coming to the 10th question. Be careful while answering. The number of nodal planes in PZ orbital is. Let me check who will answer first. It's too simple question. Very good, Gayatri, Banu, very good. Its PZ orbital means p orbital. What is the L value? L value equal to 1 and hence option D is the right answer. Too good. Anita, Lakshmi, Abhilash, too good. Let us move on to the next question. The energy of an electron of 2py orbital is. 2py ఆర్బిటాల్లో ఉండే ఎలక్ట్రాన్ యొక్క ఎనర్జీ ఎలా ఉంటుంది? ఐ విల్ రీడ్ ద ఆప్షన్స్. గ్రేటర్ దాన్ 2px ఆర్బిటల్, ఆప్షన్ బి లెస్ దాన్ 2pz ఆర్బిటల్, equal to 2s orbital, same as that of 2px and 2pz orbitals. Very good, Gayatri, Bhanu, Swati, very good. So p orbital is degenerate. So px, py, pz will have same energy. So option D is the right answer. Too good. Which of the following is not a electromagnetic radiation? Very simple question. You try to answer 12th question. Which of the following is not a electromagnetic radiation? Yes, Gayatri, Bhanu, Tilak, too good. Sriram, Abhilash, very good. Rebecca, okay, ma option B, beta rays are not an electromagnetic radiation. Okay, very good. Moving to the 13th question. It is also very simple. You just carefully answer. The energy of a photon is inversely proportional to its. I will read out the options. A, frequency, B, wavelength, C, wave number, and D, velocity. What is the right answer? Let us wait for few seconds. Tilak, Abhilash, everyone is guessing the right answer. Very good. Energy is inversely proportional to wavelength. So option B is the right answer. Too good. You people are highly talented. Okay, moving to the 14th question. The radiation with highest wave number is. Now try to answer highest wave number. Option A, X-rays, B, visible rays, C, IR rays, D, radio waves. Rajeshwari, let us wait for few seconds so that remaining students will answer. Ma, I will give you the hint. Wave number is equal to 1 by lambda, inversely proportional to wavelength. How the wavelength varies? Wavelength increases from X-rays to radio waves. So what about the wave number? Here they asked about the wave number. Gayatri, you are right. I am waiting for the others' answer. Very good. X-rays. X-rays will have least wavelength and hence they will have highest wave number. So X-rays is the right answer. Moving to the 15th question. Fund series is produced when the electron jumps from outer orbit to. Now tell me the right answer. When Fund series will be produced? If an electron jumps from outer orbit to which orbit? Very good. Tilak. Abhilash, you have to check the answer. So Fund series means n equal to 5. So option B, fifth orbit is the right answer. Everyone answered correctly. Coming to the 16th question. Among the first lines of Lyman-Balmer-Paschen bracket series in the hydrogen spectrum, which has the higher energy? You just try to remember where these spectral lines are observed. Yes, Lalita, very good. You try to answer 16th question. Banu, very good. Very good. Anita. Yes. It is Lyman series. Why Lyman series is observed in the UV region? Definitely the energy is very high in this region. So definitely Lyman is the right answer. Clear? Let us move on to the next question, that is 17th question. What is the shape of the orbital if L equal to 2? Very good. You try to answer 17th question, Swati. If L equal to 2, what is the shape of the orbital? Everyone try to answer. Just we are going to discuss only 3 more bits. You people are having enough patience. Very good. Very good, Gayatri, Abhilash, Sahiti, Vamsi. Tilak, you have to think again. If L equal to 2, what is the orbital? D orbital. So what is the shape of the D orbital? Yes, Tilak, it is double dumbbell shape. So option D is the right answer. Moving to the 18th question. The radius of the third Bohr orbit is... remaining 3 questions you have to calculate. Okay. Swati, try to answer 18th question. Which formula we will use for calculating radius? It is Bohr orbit means hydrogen atom. For hydrogen atom, Z equal to 1. So R3 equal to 0.529 into n square. N square means 3 square by 1. So now tell me what is the answer? You do the calculation and then answer. Yes, very good. Tilak, Swati. Yes, it's 4.761 Armstrong units. So option A is the right answer. Very good, Sriram. Lalita. Let us move on to the 19th question. Radius of fifth orbit of lithium plus 2 ion. Lithium plus 2 ion means it also consists of only one electron. So we can use the formula 0.529 into, here n square means 5 square. Here z equal to 3. Rajeshri, very good. Try to answer 19th question. We are about to close the session. You try to answer. Into 25 by 3. You just do the calculation carefully. Ma, you have to do the calculation carefully. What is the right answer? సాహితి ఒకసారి చెక్ చేయండి అమ్మా. Yes. Did you got the right answer? Very good, Banu, Anita, Tilak. Option D is the right answer. That is 4.4808 Armstrong units. Okay, Vamsi. And coming to the last question, that is, what is the energy of the fourth Bohr orbit? And what is the expression we have to use? Minus 13.6 into Bohr orbit means 1 square divided by n square. That is fourth orbit 16. What is your answer? Yes, too good. Everyone picked the right answer. Too good, Tilak, Swati, Abhilash, Anita, Sriram. Too good. I think that is enough for today. Have a nice day. No, I will conclude the session. Okay? Good night.